Hello everyone, my name is Kai Nellermo and I got to work with Joseph Casti and Rylan Hansen on our senior design project for Dr. Dolly Soon. Our project was titled Light Plate Apparatus because we were working on creating an array of LEDs that can fit under a standard lab 96 well tray. So there had been some previous design groups that had worked on this project, and they had come up with a board that looked a little bit like this one. That was 2020. And then in 2021, they came up with this board, which still had some flaws because the 96 well tray doesn't fit over each LED well. A few other issues with this board were they didn't have a good user interface for controlling which lights came on. They hadn't characterized the wavelengths of light coming from the LED, and there just wasn't much for code in general. That's kind of where they had reached a stopping point. And then, as you can see, there's no case that would work well in the lab either and meet the requirements for humidity and temperature and some of those other factors that we were trying to reach as engineering goals. So we came along and modified this board and created our own. So on this board, you can see we have an itsy bitsy microcontroller, same as the 2021 group, and we're sending over the serial controller different bits of data to control the exact output that we want on each of these LEDs. The itsy bitsy then communicates with an LED driver, which you can see we have 12 of on the back of our board. Now each one of these drivers is able to control 8 wells of LEDs. There's 2 pins that control the UV LED, there's 1 for the green LED, and then there's a pin for the red value of our RGB, the blue value of our RGB, and the green value of our RGB. And they act as a current sink and control the current that is applied to each LED. So you can see our new design with a 3D printed case and an LED display that right now just shows our project title, but would be able to also display the battery voltage that we have on this device. So if we were to unplug this cable, we could just flip the switch and it would be battery powered. Depending on what code we had uploaded, that's exactly what it would run. But right now, since we're still attached to the computer, we created a little user interface that you can select the exact wavelength that we determine based off of our characterization that you want to output on the LEDs. You can see that if I select one of the colors, right now it's showing green, but if I switch to select something like blue, there's going to be a little bit of a delay, but then it automatically goes to blue. And same goes for any of these, and including my personal favorite, the smiley face, which just shows that we can control each individual LED, and we have that mapping in an Excel spreadsheet. So with that, we'll show you what we did when we assembled the board in the research park.
I'm just mixing some SD405 solder paste.
So now that Joseph mixed the solder paste, we are here placing it onto our circuit board. And you can see a picture of the solder paste on the pads where it's supposed to be. After that's complete, the pick and place machine, as you see in this video, is placing the LEDs. And then the circuit board is ready to go through the reflow oven and be tested with microscopy and characterization for the LEDs, where we get the peak wavelengths, and then you can just see a close-up image of all of the functioning LEDs with the different patterns that we programmed into the device, including a couple that you saw there, like the smiley face and a little fun pattern to end. And this was the user interface that we created to simply select different wavelengths. Here's a couple photos of our group. Thanks for watching.